Okay, good. So again, for those who are late, our speaker is named Carlos, coming from Microsoft, and will present us the Infinite Hotel. The floor is yours.
Thank you. Well, thank you all very much for coming to this presentation. I'm going to be talking about the Infinite Hotel, how to scale multi-tenant platforms through a unified API. First, of course, I'm just going to introduce myself. I am Carlos Mestre del Pino. I'm an organizer on the KCD Netherlands as well. I will take the moment to do a bit of advertisement. We have an event coming up on the 3rd of July, so please feel free to join us in Utrecht. Very nice moment of the year to go visit the Netherlands, really. I'm also a cloud solution architect in Microsoft, where I help Azure customers with their Kubernetes setup environments and ramping up a bit their knowledge, and building platforms. I am Mestre del Pino on pretty much all social media. You can scan the QR code as well if you'd like to follow me anywhere. And here with me, not in the room, unfortunately, is my friend Christopher Haar. He's a Crossplane contributor. He's a software engineer in Upbound. And, well, we originally built all of this presentation and kind of project together. So I also wanted to, of course, give him a little bit of credit. Before starting, I just have to mention a little disclaimer, because I've used some supporting materials, basically images from this TED Talk, The Infinite Hotel Paradox by Jeff Dekovsky. I used it because I really like the images. It was also the first time that I ever watched anything about the Infinite Hotel was with this video. And yeah, like I said, the content is quite nice, and it was that or like Studio Ghibli AI generated images. So I decided to go for this. So first, just a little introduction for context for what was the inspiration of this talk. So this is the Hilbert paradox of the Grand Hotel, or the Infinite Hotel Paradox. And this basically demonstrates how a fully occupied hotel with infinite amount of rooms can still host more guests. It was made for humans to try to wrap our minds around the vast concept of infinity. And in this case, there's a hotel manager, which has a lot of knowledge on mathematics, which uses to accommodate more guests into the hotel. Now, of course, I will not go too much into detail, but again, just so that you understand a bit about the paradox. So let's say, again, you have a hotel, infinite amount of rooms, and they are all full, but we still can accommodate more guests. How do we do this? Well, in this case, the hotel manager is asking everybody to move to the room n+1. So the person in the room 1 will move to the room 2, person in room 2 will move to room 3, etc. There's an infinite amount of rooms, so you can always go one further. That vacates the room number 1, where you can have a new guest coming in. It also goes further, like what if you have an infinite amount of new guests? Well, the hotel manager is asking everybody to go to the room 2n. So person in the room 1 will go to room 2, person in room 2 will go to room 4, and like that it vacates all the uneven numbers. And since there's an infinite amount of uneven numbers, you can host an infinite amount of guests. It then goes on to like further levels, like deeper levels of infinity, which I won't explain because it's complex and it will be here as well all day. But what would happen if you have infinite amount of people, each of them within an infinite amount of buses, within an infinite amount of ferries? Very interesting. If you like mathematics, I definitely recommend looking into this. But we are here to talk about, Kubernetes and platforms, of course. So to set a little bit of the context of our Infinite Hotel, of course, we want to have infinite capacity. Now, I'm going to use the word infinite. Of course, we are still limited by the capacity of the cloud providers, right? If any of you know Azure West Europe, you know what I'm talking about. That capacity will not be infinite. Then we will have our hotel manager, which will be our control plane, will be cross-plane with some resources. I will be going into that a little bit more into detail after. And our hotel manager is actually using platform engineering principles to manage Kubernetes clusters, to deploy resources, and ultimately to scale infinitely. Okay, I'll just do it like this, maybe. Let's see, does it work now? No, okay. So let's go then with the components that we will need in our hotel for it to be infinite, in our platform. Still talking a bit in the abstraction before we get into the details on what each thing is. So we're going to need an infinite amount of lobbies or infinite amount of buildings in which we're going to be able to fit certain amount of floors, hopefully as well infinite amount of floors where we will host our rooms. And then, of course, we will be able to deploy an infinite amount of rooms. On top of that, we will have a gate guard, which will ensure that our guests only are allowed only into their respective rooms, and a concierge service, which will bring the guest belongings into the room. So let's look a little bit more at what that looks like. Of course, everything is defined as cross-plane compositions, composite resource definitions. And first, we have our lobby, which will be the base of everything. That's going to be our Azure VNet. Of course, I'm talking in terms of Azure. You should be able to do all of this in any cloud provider, of course. So on the lobby, which is the network, right now it's super simple. We're only even defining the wing, right? So West US, that will be the region. And of course, you should have other things in here, such as, like CIDR ranges, and anything else that you want to configure on your network. After that, we will have our floors. So those are the actual AKS clusters that will get deployed within that VNet. And in here, we're defining certain things, such as well, the lobby. So what network should this cluster be deployed into, or what network should it consume? We also, right now, still have the region in there as a wing. Ideally, this and some other examples later will be already inherited from the floor, right? But yeah, that's as well a little bit more kind of like complex to build, and we will get there. We will get to that eventually. We have the occupancy permit, which maps to the Kubernetes version that you want in the cluster. And we also have a little typo there, the square meters. That's a little bit about the sizing of the cluster. So we have 3 nodes and the room class, which is the basic suite, which will just map to a VM size in Azure. Going further, inside of every floor, we're going to have a room. In this case, the room are going to be loft V clusters, as was just mentioned at the beginning. And in here, we will also define like what floor is it in, what lobby, again, hopefully should be inherited from the floor in the future, as well as what gate guards should be used to provide the access into the room, into the V cluster. On top of that, we will have the tenant, because ideally, you might have different rooms, different V clusters, and you want to have like a tenant that can have access to the different clusters, not a one-to-one mapping. And also, we have the coordinates of the room, which is just the the DNS for the ingress, like the suffix. We also have, of course, like I said, our gate guard that is key cloak deployment, and in this case as well, we're defining, okay, what lobby should it be in, what floors, or what AKS cluster should the gate guard key cloak be deployed into, and as well, yeah, we have in there as well example name, example tenant ID too. Going further, we also have, of course, our concierge, that is an Argo CD deployment, and that's the one that's bringing the guest belongings into the room, right? So guest belongings would probably be, any kind of application, any kind of YAML, any kind of Kubernetes resource that will be deployed into the cluster. Once again, in here, we will say what floor it is in, As well, we will add the name of the concierge and which gate guard should be used. So we have as well some integration of Argo CD with Keycloak, although that's not even that interesting to show. We then have, of course, the tenant. So like I said, that will map to, well, Keycloak realm, Keycloak clients, client scope, especially. So anything that you will need, let's say, to get into the cluster or into multiple clusters, really. And of course, we will have our guests at the end, which will just be users that will be part of a tenant. So I mean, here we're defining as well basic metadata, right? So like what is the name of the user, email, etc. An initial password as well, which is not in the screen just because it would be too long, but yeah, just any password, you know, that will be assigned to that user default. So let's look at how all of this fits together. So a little bit look at the architecture. First, like I mentioned, we have our hotel manager. That is a cross-plane deployment together with the cross-plane provider. So of course, as we've mentioned, we have a provider for Keycloak, provider for Azure, and then for Kubernetes and for Helm for deploying things both into the AKS clusters and the V clusters. Then when it comes to the access, so that will be the cross-plane provider configs. We will be deploying a provider config per a Keycloak one per gate guard, an Azure one per subscription, which in this case we only have one, and as well both Kubernetes and Helm provider configs per floor. So just for you to once again kind of visualize a little bit more. So again, we have our lobby, so our network, which will have an AKS cluster inside. We will be deploying certain services in there, such as, well, nginx ingress to access the V clusters and also like all the other services. Cert manager configured with Let's Encrypt. And we also have a small room service. So that could be any kind of service that goes from the host cluster onto the V cluster. We then have the room, of course, which is the V cluster, so that's what the users will be accessing. And, of course, the gate guard and the concierge. In this case, deployed into the same floor as the room, but again, you can pass all the parameters on the definition of the room, so it's not necessary that they would be together. So then what the guest can do is, well, talk directly to the concierge to hand the belongings, and also talk to the, well, go through the gate guard and get access granted into the room. And like we said, there's also, well, we also have the room service. So in our case, the guest ordered a paella, and I do hope that they really like it because it's going to be an infinitely large one. Moving on to our common platform scaling challenges. Well, we have grouped them a little bit in four. I'll show you now. But basically, if you want to have a platform that will infinitely scale, right, that will be multi-tenant, that will be multi-control plane, that's not going to come without any challenges. So let's look at the different multiple layers that and challenges that you will have. Of course, you will first deal with security and workload isolation. You'll have the scaling challenges in general, service to infrastructure mapping, and shared versus centralized service scaling. And now we're going to go a little bit more into detail of all of them. So when it comes to the security and workload isolation, it does get complex quite fast. The isolation between tenants can happen at different levels, right? Because you have, of course, network isolation, you have compute isolation, so what nodes are those workloads running in, even if it's all in the same cluster, or different clusters, of course. You have the Kubernetes API and etcd, right? Like, is it going to be a shared etcd or shared API, or are you going to have like different ones? So that's where big cluster kind of comes in. And as well the supporting services, so the Argo CD, the Keycloak, you know, how how many Argo CDs do you want? Do you want that per tenant? Do you want that per cluster, right? That's the kind of things that you need to understand. And of course, when it comes to that isolation between the tenants, that's going to be highly dependent on, well, both company policies and as well like who your tenants are, who the consumers of the platform are. If you're servicing the platform to like internal developer teams in your organization, there's usually going to be more flexibility about the isolation than if you're servicing that to like external companies, right? In that case, they're probably going to have very, very strict isolation requirements. You also might have to deal with misconfigured network policies, right? Because at the end, if you're deploying vClusters into a host cluster, you want to, obviously, they are going to be into different namespaces. You want to really restrict the traffic across those namespaces if you have multiple tenants. And introducing a bug into it, it could, let's say, cause that you just open the traffic across all the tenants. So that's also something that you need to be very careful with. Additionally, there's the overly permissive access control. So in our case, of course, of cross-plane, if you are servicing a claim to a customer and they can choose the provider config, so what target, what cluster should be deployed into, then you're basically allowing your customers to deploy things into other tenants, even if they don't get access after or if they do. So it's important to bear that in mind, which, for example, we don't quite have that in our setup. Additionally, you're going to be dealing with, well, any kind of scaling challenges. Like at the end, it is not magic. It is architecture, right? So what's happening when you're deploying and managing hundreds of providers and control planes, right? You're going to have to deal both with the scaling of that control plane. Do you have multiple control planes? Do you have one? And as well with all the management overhead, because if you say that you have hundreds of floors, hundreds of AKS clusters or V clusters, they might have different versions, right? You're deploying all the providers, all the provider configs, right? So there's quite a challenge when it comes to the management of these platforms that get that large. Then you have, of course, the state management across clusters, because if anything happens to the control loop to the reconciliation loop between your control planes or cross-plane and any of your other resources, then your desired state might be different from your actual state. So that's also something that you always need to make sure that it's constantly working. You need to be monitoring that as well, of course. We also have the service to infrastructure matching or mapping, and this isn't just technical. This is also strategical, right? So it's important to map the right services to the appropriate infrastructure components, and also to understand a little bit the way that those components work, right? So for example, when you deal with something like Keycloak, Keycloak does have a multi-tenant model within, which is the Keycloak realms. Argo CD, kind of, you could say, with the Argo CD projects, right, where you can limit the clusters that something can be deployed into. So it's quite important that you also understand like, those services. How are they going to map to what you're going to end up, how you're going to end up deploying, and how it's going to be consumed, of course. You then, of course, have the number and instance distribution. So again, are you going to deploy an Argo CD per tenant? Are you going to do that per cluster? Of course, there's different levels of complexity. The more you share resources, the more you're going to have to, well, take care of some things. If you're just, giving a complete new deployment to a new tenant and there's no other tenant using that component, then of course that will be easier, but you're going to have more components to manage. And it's very important to understand as well the load characteristics, replication needs, and like failure domains. So as well, like when is your component too full? When is there too many realms, right? When there are too many applications managed by Argo CD. Example of Argo CD, for example, it's a good one to with the UI, right? Because perhaps the Argo CD itself is able to manage like a lot of applications, but then you might be trying to access the UI and it's buggy, and if you're giving that, not buggy, but it's very slow, and if you're giving access to your customers to that, then they're not gonna have a very good experience, right? So you kind of need to understand what the limits are for each of your platform components. We then have, of course, the shared versus centralized service scaling. So again, this is just a little bit building on the previous point. And at the end, it's important that you're going to be doing like pilot deployments, load testing, right? You want to be able to understand how your platform is going to scale before you deploy it, right? Because otherwise, you're just going to end up, focusing on fixing it in production, and that's going to be a nightmare for you, and it's going to be a nightmare for everyone. So it's really, really important to understand the high availability, performance, and recovery as well of all of this, of all of these components, so that you can build and design a proper architecture. A lot of challenges, but don't worry. It all does start with a great API design. You need to design for flexibility, for composability, and clear contracts, right? So what are your developers, what are your platform customers consuming, right? And then scaling just becomes an architectural choice, not an afterthought. So you really need to plan from the beginning as much as possible. Of course, eventually you're going to run into things, like you don't know what you don't know. You're going to get into challenges, but that's why it's so important that you're going to be planning and testing your architecture. So now we have a little bit of a demo, which I have in a recording to make sure that it was all good. After someone did recommend me this yesterday in the speaker dinner. What I'm going to be demonstrating is not the last version pushed into here. Again, this is all still in development, and yeah, even some of the things that are demonstrated are not fully baked into the automation yet, but I do hope that probably by the end of the month will be. Okay. So first, just going to display a little bit of the resource. Oh. Is this only sharing the PowerPoint? The screen is... okay. Okay, so apologies, I just have it down here. So first, I'm just going to start, let's say, displaying a little bit the resources for those that are not very familiar with Crossplane. At the end, you're creating all these abstractions, which you're exposing as Kubernetes CRDs. So first, we're going to look into like the different lobbies that we have. We have there like lobby 4, lobby 3, lobby 0, and of course, those are mapping to the Azure networks, to the different VNets, which also gets displayed into here. We then go into look at you can see how they are mapping the different networks, even how the names are also different. So of course, you can do any patching so that the actual resource will be different from the name of your CRD. We also look at the floors, those are the AKS clusters, of course. And we go into display as well with Azure CLI what those clusters are really called. So in this case, you see that our floors from the Kubernetes perspective are floor 4, floor 1, floor 2. But then when we look, we can see that the name of the clusters themselves are, of course, different. So in this case, we have like what lobby, what floor, right? So that's usually when you create your cluster, you put what VNet is it deployed into, what name, of the cluster you have, etc. So that's also some of the things that, you're allowed, let's say, that you can do with Crossplane. We then look at the different rooms. These are like completely reconciliated from Crossplane. Like I said to you, the authentication part, it's still not baked into, so I did deploy the cluster still with Helm, still with Crossplane with a Helm release to display a little bit the authentication. We look as well at the different the concierge deployment of our concierge, of our gate guard, of our tenants. So we just make sure that we have all the different resources in there. Then after that, we're just going to use some curl commands to display that we're also authenticated in there. So we just have some variables in there, like what is the keycloak endpoint, like admin user, etc., which is going to be used to log in. Although, like I said, still being built, but we do have some of the integration with Azure AD. So the idea is that you will use Azure AD to log in into the vClusters, right? This is just a little bit the display. So once you do your kubectl OIDC setup command, it will open keycloak, and then you can use your Azure AD to authenticate against the cluster. Like I said, so further, some of these things are not automated. So for, going on from here, we're using the admin account. First, we're going to be looking at the kind of token that you get. This is very important, actually. This is something that made me crazy for a couple of days, because I'm not a keycloak expert. It's something that I'm learning still. And when you're using OpenID Connect, you're actually using the ID token, not the access token, to log in into the cluster. And it's important to see as well the the scope, that the token has the scope to use groups for authentication. We then, of course, just writing that output into different variables, which we can reuse in the two commands following. So first, we're displaying a little bit of the user information. So you can see that I am the admin user, and you can see that I'm part of all of those groups, specifically the admins one. And then finally, we can look at we can get authenticated against the cluster by using the pods, by grabbing the pods, let's say. Going on a bit on how these configurations look as well in Keycloak. You have, of course, your Keycloak client. This is right now on the master realm. We have our room in this case, which, of course, you need to make sure that you configure the valid redirect URIs, as well as having both client authentication and authorization turned on. This will, of course, have a credential, so a password that you can use to consume from that client. And then you need to create a role. In this case, we have the admin's role. And your client also needs to use the group's client scope, which itself you also need to configure a couple mappers, so the full name and the group, so that you can authenticate either as well passing your username, or you could have the email as well instead, and as well the OIDC group that you're part of. Of course, you will also need to create a group. We have this admins group, which both my local admin user and my Azure account are part of. And of course, you will need to have a role mapping back to the role that you created in the client. And just to show you a little bit quick as well how this is working. Well, of course, this is right now public. Like I said, not all the things you saw are pushed into the latest version yet. But it's good to see that you have as well in here all the dependencies, right? So some of them are custom functions that I will quickly show you. Now, and as well some other are external. You then have, of course, your different XRDs. So for the floor, here's where you should have documentation. Don't have it empty like I do right now, because then you're going to spend a lot of time with your customers. And then just to show you very quickly what one of these functions look like. So in my case, I did it with KCL language. You could do with Python. You could do with Golang, right? But at the end, for those who have used crossplane before the composition functions, you ended up with this like massive YAML files because it was all through patching, and this allows you to build a lot of logic as well into the composition. So with that said, thank you all very much. And yes, if you want to ask any questions, please feel free.